I'm Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. And today I am going to discuss about the subject electronic measurements and instrumentation. Coming to the subject, the main course outcomes are at the end of the course, the student should be able to recall the schematics of measuring system and performance characteristics of an instrument. And second one is describe the basic building blocks of cathode ray oscilloscope and cathode ray tubes. And finally, at the end of the course, the student can able to design a measuring instrument on requirement basis. These are the course outcomes for the EMI subject. And coming to the syllabus present in this measurements and instrumentation, the first unit is electronic measurements and instrumentation. Here we have block schematics of measuring system, performance characteristics, static and dynamic characteristics. And what is meant by measuring system means, here in this measuring system we measure a particular quantity. How we are measuring a particular quantity is described in the measuring system and block diagram of a measuring system. Next one is performance characteristics. What is meant by performance characteristics? How a system performs with respect to time t or without time t, that can be defined as a performance characteristics of an instrument. So here we discussed about performance characteristics of an instrument, which comes under static and dynamic characteristics. Again, in the static characteristics, here we discussed about different parameters like accuracy, resolution, precision, Gauss error, and different types of errors. Similarly, we also discussed about dynamic characteristics of an instrument. Those are repeatability, reproducibility, fidelity, and lag. Along with these characteristics, we also discussed about analog measuring instrument like D'Arsonval meter, DC voltmeters and ammeters, AC voltmeters and current meters, ohm meters, multimeters, and meter protection and extension of range, digital voltmeters. In these digital voltmeters, we have ramp type, staircase, dual slope integrating type, and successive approximation type. So, before going to study about this block diagram of a measuring system, what is meant by measurement and what is meant by instrument and what is meant by instrumentation. Instrument is a device which is used to measure a particular quantity, whereas instrumentation is the process how we are using a particular instrument to measure a parameter. That is the main difference between instrument and instrumentation. Here in our syllabus we are measuring different parameters with the help of different instruments. In the first module, mainly we focus our attention on different instruments, how we are using those instruments in our laboratory purpose. Mainly we have DC meters and AC meters. In olden days we are using analog meters, but while we are using the analog meters, we have so many problems like parallax errors can be obtained and sometimes reader cannot calculate accurate readings. So to overcome these parallax error and reading error, we go for digital meters. In the digital meters, we have ranges from one certain, we have so many ranges of digital meters so that we can find out the meter reading accurately. In the first module, we mainly discuss about different types of meters with respect to voltage, current and resistance. So we have voltmeter, ammeter and ohm meter. What is meant by voltmeter? Voltmeter is mainly used to measure the voltage, whereas ammeter is used to measure the current. Similarly, we have another device that is called as ohm meter. This is mainly used to measure the resistance. So we have three different devices like voltmeter, ammeter and ohm meter. to measure voltage, current and resistance. But if you want to measure 3 parameters, every time we need to use 3 meters. Instead of that, we are using simple device called as multimeter. The name itself indicates that with the help of multimeter, we can measure all these parameters by using a single device. That is the advantage of multimeter. So here we discussed about, in the first module we have voltmeters, ammeters and multimeters, how they are working, the construction and principle of voltmeter, ammeter and multimeter. These 3 parameters are discussed with analog meters as well as digital meters. And next one is digital voltmeters. How we are using digital voltmeters to convert frequency to voltage and frequency to time, or voltage to frequency and voltage to time. We have different types of digital voltmeters like ramp type, staircase, dual slope integrating and successive approximation type of digital voltmeters. All these are helpful to convert voltage to frequency and voltage to time. Finally, from the first module, we have discussed about different characteristics of an instrument like performance characteristics, which include static and dynamic characteristics. Next, what is meant by voltmeter, ammeter and ohm meter. How we are using our PRs, D-Arsenval movement or PMMC meter or D-Arsenval meter can be helpful to measure voltage, current and resistance. And finally, we have discussed about different types of digital voltmeters. This is the syllabus for first module. Coming to the second module consists of oscilloscopes. Here in this second module, we mainly focus our attention on different types of oscilloscopes. What is the need of oscilloscope? As we know that normally the voltmeters or ammeters are helpful to measure voltage or current, but we cannot find out the waveform with the help of meters. So we are using these oscilloscopes. This oscilloscope consists of CRT screen. That screen consists of horizontal and vertical axis. Horizontal axis is represented with X axis and vertical axis is represented with Y axis. So along X axis it represents the time period, whereas along Y axis it represents the amplitude. So by using this oscilloscope, we can find out the waveform. Along with the amplitude, we can measure the variation in the output with respect to time t. That is the advantage of oscilloscope. If you are using normal voltmeters or ammeters, we cannot get the readings. If you are using voltmeters or ammeters, we can find out voltage or current readings, but we cannot view the output waveform. But with the help of oscilloscope, we can view the output waveform by using CRT screen. In this oscilloscope, we have different types. They are special purpose oscilloscopes, dual trace oscilloscope, dual beam CROs, sampling oscilloscopes, storage oscilloscope, digital storage CROs, Lissajous figures, frequency measurement, phase measurement and CRO probes. Here in this second module, we mainly focus our attention on different types of oscilloscopes and how these oscilloscopes are helpful to find out output voltage or output current that varies with respect to time t. And next one is the third module. In this third module, we have different types of signal generators and signal analyzers. First of all, we have AF and RF signal generators. What is the need of signal generator? Signal generators are mainly used to generate different types of waveforms. Here we can generate a sinusoidal signal, or we can generate a triangular wave, we can generate square wave and ramp signal. These are the different types of signals that we can generate with the help of signal generators. So we can generate both low frequency signals as well as high frequency signals. All the signals can be generated with the help of signal generator. What is the need of generating these signals means, if you want to check any circuit with the help of input signal, that input signal can be available from AF and RF signal generators. All low frequency signals are operated at AF signal generator, whereas at high frequencies we go for RF signal generators. Now here we have different types of signal generators like sine wave signal generator, square wave function generator, arbitrary waveform generator, sweep frequency generator, video signal generator, and specifications. These are the different types of signal generators. Those are helpful to generate different types of signals like sine, square, triangular, ramp, and many more signals can be generated with the help of these signal generators. Now we have signal analyzers. We have AF and HF wave analyzers, heterodyne wave analyzer and harmonic distortion analyzers, spectrum and power analyzers. Here the signal analyzers are operated at high frequencies to represent output waveform. And normally the spectrum analyzer is also used as a oscilloscope, but in the spectrum analyzer the main advantage is here we represent each and every amplitude with respect to frequency. Normally if we are using a CRO, the x-axis represents time period, whereas y-axis represents amplitude. But in spectrum analyzer, the x-axis represents frequency and y-axis represents frequency and y-axis represents amplitude, so that it can operate for high frequencies. So in the signal analyzer we will discuss about different types of signal analyzers. In signal generator we will discuss about different types of signal generators, how these signal generators will generate the signals. And next module is bridges. In this we have two types of bridges. In the syllabus we have two types of bridges, AC and DC bridges. What is the need of bridge? Why we are studying about these bridges means, bridges are mainly used to measure the unknown parameters. In this, the unknown parameters are R, L, G, C. R, L, G, C. These are the four unknown parameters that we can measure with the help of bridges: resistance, inductance, conductance, and capacitance. How can we measure these four parameters means, by using a bridge setup. Normally, the bridge consists of four arms. This is a bridge setup. In this, we have four arms: first arm, second arm, third arm, fourth arm. The two opposite arms of the bridge are connected to a meter, whereas the remaining two arms of the bridge are connected to a galvanometer. So, normally the bridge consists of four arms: arm 1, arm 2, arm 3 and arm 4. Among these four arms, the two opposite arms of the bridge are connected to an AC or DC input. The remaining two arms of the bridge are connected to an galvanometer. So if you connect like this, in these four arms, if any one arm is an unknown arm, that is, this is unknown resistance. We know the values of first arm R1. We know the value of second resistance. We know the value of third one. But we don't know the value of fourth resistance. In this case, by balancing the bridge condition, we can find out this unknown resistance with the help of these three resistances. This is the process present in the measurement of any unknown parameter with the help of known parameters. Here we can apply two types of inputs. If you apply analog input, then it is AC bridge. If you apply a DC voltage here, then it comes under DC bridge. The DC input voltage is given to DC bridges, whereas AC input voltage is given to AC bridges. But whether we are finding either resistance, inductance, conductance or capacitance, in any of these parameters, if you want to measure any of these four, always the bridge consists of four arms. By making the balanced bridge condition, we have to find out unknown parameter. How to balance the bridge means product of two opposite arms must be equal. That is, the two opposite arms R1 and Rx are two opposite arms. Similarly, R2 and R3 are two opposite arms. The product of two opposite arms R1 into Rx is equal to R2 into R3. The product of two opposite arms must be equal. From this, we can write R1 into Rx equal to R2 into R3. From this, unknown resistance Rx equal to R2 R3 by R1. In a similar way, we can measure these unknown parameter, whether we have resistance or if you have capacitance parameter here, we can represent in terms of capacitance. So, irrespective of an element, based upon the balanced bridge condition, we can find out the unknown parameter by balancing the bridge. How to balance the bridge means by equating two opposite arms. Product of two opposite arms must be equal. This is about bridge, how to measure unknown parameter with the help of a bridge, and what are the different types of bridges we have. In our syllabus, we have two types of bridges, AC bridges and DC bridges. As we have discussed that AC bridges consist of input signal as the AC input, whereas DC bridges consist of input signal as the DC input. We have different types of bridges like Wheatstone bridge, Kelvin bridge and Maxwell's bridge, Hay, Shearing bridge, Wien bridge, Anderson and Wagner and ground connection. This is the syllabus for measurements bridges. Next, last module is the transducer. In this transducer, we have discussed about different types of transducer, what is meant by transducer, classification, and how they are used in the real world. So, what is meant by transducer? Transducer is a device which converts one form of energy into another form of energy, or it can convert non-electrical energy into an electrical energy. So, transducer is a device which converts non-electrical energy into an electrical energy, or one form of energy into another form of energy is called as transducer. Coming to the classification, we have different types of transducers like resistive transducer, inductive transducer, capacitive and conductive transducers. So in this resistive transducer is again we have strain gauges, resistance thermometer, all these comes under resistive transducer. Along with this we have force and displacement transducers, hardware anemometer, LVDT, thermocouples, piezoelectric transducers, variable capacitive transducers, magnetostrictive transducer, measurement of physical parameters, flow measurement, displacement meters, liquid level measurements, measurement of humidity and moisture, velocity, force, pressure, high pressure, vacuum, and temperature measurements. In this fifth module, we mainly focus our attention how we can convert one form of energy into another form of energy. And the prescribed textbook for this subject is Electronic Instrumentation by H.S. Kelsey. So, in this electronic measurements and instrumentation, mainly we have discussed about what is meant by instrument. What is meant by instrumentation? What is the difference between instrument and instrumentation? Instrument is a device which is used to measure particular quantity, whereas instrumentation is the process how we are using a particular instrument to measure the parameter. So in this electronic measurements and instrumentation, in this electronic measurement and instrumentation, we have studied about different types of electronic instrumentations, how they are working, how they are helpful to measure different parameters in real life. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.